Okay, graph the quadratic and write its domain. Okay, so we're giving you a table here. So what's negative 2 squared? Negative 2 times negative 2 is positive 4 plus 2, you're going to get 6. Okay, you're going to get 6 there. Negative 1. Negative 1 squared is 1 plus 2, you're going to get 3. 0 squared is 0 plus 2, you'll get 2. Right, 1. 1 squared is 1 plus 2, you get 3. We're going to be repeating these numbers from the top of the table. 2 squared is 4 plus 2 is 6. Okay, right, let's have a look at this. Here we go. Negative 2 produces a 6. Negative 1 produces a 3. 0's got a 2, then back up again. Always remember these curved ones, okay, parabolas. Don't do a V shape, it is hopefully a nice smooth curve. Okay, there we go. That's that. Now, by the way, I forgot about the domain. Remember this one, that domain of the root x minus 4? I think the graph was something like this. You know, it kind of went. Okay. Well, the domain is this. It starts at 0 and goes on to infinity. So that was the domain of that square root one I did earlier. Okay, I forgot about that one. Sorry about that. Okay. The domain of this, there always will be from negative infinity, because it'll go on forever this way. So if you're reading x values, I know it's going up, but that is nothing to do with domain. That's range. That's something different. This is also going up, but it's going to the right, which is infinity, and that's the domain. Okay, negative infinity to positive infinity, which actually all squared graphs, not square root graphs. There was the square root graph. They'll always be like that. Because this one here, same thing. Now, if that's on, you're going to do the same thing. I know that's going to be something like this. It's going to be over here, right? I know it's that one because there. Okay, it's going to be over there. But anyway, if that's on, you know, just do the same kind of thing. The domain again will be negative infinity to positive infinity. Okay, so that was a quick one there. Let's keep on going. Nope. I think this is the last one. Is this? Let's go. Uh-oh, the word problems. Okay, let's have a look at this. Right, a triangle. If that's x and the other one's 4 feet longer, this is x plus 4. If we're trying to find what x is, well, all this is a right angle triangle. It's Pythagoras' theorem. It's going to be x squared, the shorter one, plus the longer one, squared, equals the hypotenuse, squared. Okay, 10 squared. Okay, there we go. So that's x squared. This second part is a FOIL. It will give me x squared plus 8x plus 16. Remember, it's x plus 4 times x plus 4. It's not just the x squared and the 4 squared. People always tend to miss out on this middle term here. Okay, this one here. And that is 100. Okay, so let's keep it going. Here, we have 2x squared plus 8x plus 16. Okay, plus 16. Of course, you have to set things equal to 0. Okay, so I'm going to take away 100. Here we go, set equal to 0. I'm going to take away 100 from both sides. If I do that, if I take away 100, what do I get? I get 2x squared. Still the 8x. And now what's this? What's that? Negative 64? Negative 84, sorry. Negative 84. Now be aware of this. You can divide these three things by 2. Let's pull it out. X squared plus 4x minus 42, alright, equals 0. Okay, so any two numbers, am I really wanting to do that? Okay, so anyway, folks, here it is. You're going to factor that, okay? If you can't, it's the quadratic equation formula again. I'm not going to go through that one, but that'll give you an answer, okay? It'll give you two answers, but remember, one of them might not be real, it might be negative, in other words, okay? You want the positive answer for this one. You want one answer. What do you think x is? You know, it might be 2 feet or 3 feet. It's going to be something like that, okay? This one might be, you know, 6 feet or 7 feet or something, and then 10 feet across. So, logically think what it might be. Okay, quadratic equation formula if you need it. Maybe it'll factor, I don't know. Right, same for this one. Okay, might be this last one actually, because this might be the last one on the test. When something finally hits the ground, the distance from the ground is 0. Okay, just keeping the same old equation on this side. 64t plus 80. Now look, just like I divided all of this by 2, all of these will divide by, believe it or not, negative 16. I know you can do 16, but negative 16 will make this first term positive. Look, divide it by negative 16, you get t squared. Divide this by negative 16, you get negative 4t. Divide this by negative 16, you get negative 5. I've divided each one of those by negative 16. Now here's the thing about this is, depending on what the last number is, you're either going to be able to factor it, or you're going to have to use the quadratic equation formula again. This is really nice because you can actually factor this. Okay, remember, all equals 0. Okay, still equal to 0. Right, two numbers that make negative 5 when you multiply, negative 4 when you add, is negative 5 and positive 1. Okay. Right, so what is the answer going to be? Okay, let's have a look. T will be 5 here, what makes it 0, a 5, and T will be negative 1 here. Well, you can't have negative numbers, it must take 5 seconds to hit the ground. Okay? And you would do, well, this is not going to be on the test, but just out of interest, so what time will the ball be 215 foot above the ground? Not hitting the ground, 219, sorry. You just put 219, not 0 on this side, okay? You'd just do that. Okay, same thing again. And, you know, unfortunately, you'd have to deal with that one. That's horrible numbers. But I'm just showing you what you would have to do, okay, if that was on. I don't know if it's on the test anyway. You know, I would, you know, you're going to have to put it equal to 0 somehow and maybe factor or the quadratic equation formula again, okay? So be aware of that, okay? On this one here, remember, it might not be factorable. You might have to use the quadratic equation formula. Fingers crossed that you can factor it, okay? And that's the test, folks.